Today we're going to look at two different ways to measure variation in a data set: range and standard deviation. Range we looked at yesterday. It's when you take the greatest value in your data set minus the smallest value in your data set. So if we're looking at this data table right here, the greatest number in the data table is 31. Subtracting the smallest number in the data table, which is 19. And the range in this case would be 12 years. That is the span of ages in the data table. The one disadvantage of using range to describe the spread of data is that it's only using two data values out of the entire table. Standard deviation is another way we can measure variation, and standard deviation is far more detail-oriented than range. Standard deviation is a measure of how much a typical value in the data differs from the mean. How much a typical value in the data set differs from the average or the mean. To find standard deviation, there's actually quite a process that you need to go through. The first step in finding the standard deviation is to find the mean. Clearly, by the definition, we need to know the mean to begin the process of finding the standard deviation. Step 2 is to find the difference between, remember difference means subtract, find the difference between each value and the mean. Okay, step 3 in finding standard deviation is to square each difference. Step 4 is to find the mean of all the squared differences. And then the final step here is going to be to square root your mean, your average answer. So yes, standard deviation is far more of a process to figure out than range, but it is far more specific than the range on how a set of data varies or how a set of data is distributed. So these 5 steps will make a lot more sense when we go through an example. Okay, in the example, I want to look at this data table, and we're going to start with step 1, find the mean or the average of this set of data. Okay, so I'm going to I have all my data here on the far left. Step 1, I'm going to find the mean all this using Desmos, the Desmos graphing calculator. So here in Desmos, I need to type in all of my data, and I want to find the mean. So click on your keyboard, go to Functions, make sure you're in Statistics, and then find the mean. And now I want to type in all of the data from that table: 20, 19, 25, 27, 30, 21, 29, 22, 27, 29, 20, and 31. Okay, and Desmos does the work for me, giving me the mean right here in this lower right box, which is 25. So going back to this table I made, kind of breaking up the 5 steps, the mean of all this data is 25. Okay, now step 2, going back to our list, step 2 is to find the difference between each value and the mean. Remember, difference means subtract. So I have to subtract 20 minus 25, 19 minus 25, and get each of those differences. All right, 20 minus 25 is -5. 19 minus 25, -6. 25 minus 25, 0. 27 minus 25 is 2. 30 minus 25 is 5. 21 minus 25 is -4. 29 minus 25 is 4. 22 minus 25, -3. 4, -5, and 6. Okay, so that's step 2, is to find all these differences. Step 3 is to square each difference, or raise each difference to the second power. So now I'm going to do that. -5 to the second power is 25. -6 squared is 36. 0 squared is 0. 2 squared is 4. 5 squared is 25. -4 squared is 16. 4 squared is 16. And then just continuing to square each value in my table gives me this list here. That's step 3. Now, step 4 is to find the mean of all the squared differences. So find the average of this list of numbers. So again, I'm going to go over to Desmo. And in this second box here, I'm going to go to functions and find the mean again, typing in all those squared differences. 25, 36, 0, 4, 16, 16. All right. So here is the average of all of those differences squared. I'm going to round this to 17.7. Okay, so step 4 in my 5-step process is to find the averages of the differences squared, which we did, and that is about 17.7 rounded for all of this. The final step is to square root your mean answer. My mean answer is 17.7. If I take the square root of 17.7, that's going to equal about, again, I'm going to have to round here, 4.2. Okay, this right here is my standard deviation. Again, this represents how much any typical value in the data set differs from the mean. Okay, there's about a 4.2 variance. Now, finding the standard deviation is quite a process. Luckily, Desmos makes finding the standard deviation quite easy, and I'll show you how that looks. Okay, so my original set of data was what I did up top right here. I'm going to just copy and paste all of this. Okay, and if you go back to functions here, there's the mean button that we've been using and the median button that you used quite a bit yesterday. And then there's 2 kind of standard deviation buttons. STDEV is the standard deviation of a sample, and STDEVP is the standard deviation of an entire population. You're going to use this button here, STDEVP, because we're assuming that the data in our table is representing the whole population of who we want to look at. Okay, so click this button here, and then I'm just going to copy and paste my data, and I get the same answer that I did doing all those 5 steps before. The standard deviation rounded is about 4.2, which is what I got here. So I did want to do all of this work just to show you guys the process of finding standard deviation by hand, and so you have a deeper understanding of what finding standard deviation looks like. But you guys are free to find all standard deviations using Desmos. Okay. To close this lesson, we're going to do one more problem here. Find the mean, median, mode, range, and standard deviation when each hourly wage increases by 50 cents. Okay, so here's my data. And the way I'm going to do this is by finding the mean, median, mode, and range, and standard deviation of the data, and then going back and adding this 50 cents to my answers. Okay, so again, I'm going to use Desmos to do this work. About 2.6 rounded. So I've written down all of my answers that Desmos helped me find really quickly. At the beginning of the problem, notice though, they asked us to find each of these things when the hourly wage had increased by 50 cents. That means I need to add 50 cents to my average, 50 cents to my median, 50 cents to my mode. Okay, range is not going to change because if you added 50 cents to $17 and if you added 50 cents to $8.75 and subtracted the two, it's still going to come out to $8.25. So range is not going to change either way. Same idea goes for the standard deviation. If you're adding 50 cents to everybody's wages, that's not going to change the distribution or variation amongst the data. So these two are going to stay the same, even though the hourly wage is increasing for everybody by 50 cents. It's the mean, median, mode that we're going to have to adjust. So 10.15 is my mean, adding 50 cents, 8.75 plus 15 cents. All right, so the mean, median, and mode with the hourly wages each increasing by 50 cents are now $10.65. Median is $9.70 and mode is $9.25. The range and standard deviation did not change since every wage was increasing by 50 cents exactly. Okay, so these are my final answers.